This is a screencast where I'm going to do Quest 8 of Everybody Codes event 2024. Quest 7 did not go well in Part 3. Part 3 took me way too long. Let's hope I can finish this up and finish everything on Quest 8 in a reasonable amount of time. I have no idea what Quest 8 will be, but let's start by creating the directory Quest 8, and then I'm just gonna copy a main file in, and here I'm just gonna delete everything here for parts 2 and 3 because by the way, check out my other screencasts for Quest 6 and Quest 7. Both of those went okay, I guess. And here, just so that it compiles, we'll save that. Okay. Make sure I'm not looking at the wrong input. Let's take a look at Quest 8. Quest 8, Shrine for Null Pointer. Know the Knights of the Order of Exceptional Architects. Okay. Priest wish to rest a new god null pointer, protected loss. Certain structure must be symmetrical, especially one highest point. First proposal, pyramid shape design. One block for each block to the side. Center will be thickness of the subsequent layer. Pyramid, the thickness of all layers. To the left and the right, to all columns that existed. Okay. The layer contains a first layer contains a single block of stone, 3 blocks, the third is made of 5 blocks, and for the fourth 7 blocks are needed. Okay, the number of blocks is limited. Quantity at your disposal. The king is also agreed. All layers are completed. Knights wonder how wide final structure be and how many additional blocks of this order. Okay, so your node is a single number, the number of available blocks 13 with that additional 3 mark, so the final structure's width is 7. Seriously? Okay, so the reason I said seriously is because this looks to be really simple, because the total number, let's look at the total number of blocks after some number of layers. After 1 layer we have 1, after 2 layers we have 4, after 3 layers we have 9 blocks, and after 4 layers we have 16 blocks, if you just add up 1 plus 3 plus 5 plus 7. Okay, so it's just a number squared. Okay. So part 1 should be kind of ridiculous. Let's get I mean, part 1 here I could do without a part 1 here I could do on the calculator on my phone. Actually, do I have calc? Let's see if I can actually do this. So we have 4098123. Okay, and the square root of that is 2024 ... Okay, so the final number of blocks will be 2025 squared minus 4098123 2502. Okay, so we will need 2502. So 2502 is one value, and then if 2025 is the last layer, then the width of the thing will be 2024 2025. Okay, so that times thing from memory 10130,598. So okay, so I did not actually need to write any code for that. I'll go back and write some code in a little bit, but I just want to read part 2. But that was kind of ridiculous. Sadly, it's really impressive. One of the nice proposes only the thickness of the layers, generating layers thickness recursively. Start with a layer of thickness 1. Multiply the thickness of the previous layer by the current number of priests of null pointer. Take the remainder of dividing the result by the number of... Okay. So... Okay. Okay, and thickness is a little bit weird. Okay, so the thickness is the amount they add on the top. Interesting. Okay. Okay, so let's download this and move over. Okay, so fine, we'll do this properly. Data a to I of string of data, and then layer equals 0 for layer times layer less than n layer plus plus. What do I want to do? I want to do print 2 times layer minus 1 times layer times layer minus n. Okay, so let's go run quest 8. Come on. 101.30598. Okay. Now, okay, we are getting 2. Okay, so, okay, and what we are going to do is we're going to say for each. Okay, so okay. Thickness of the previous layer by the current number of priests of null pointer, your notes. Oh, wait. Actually, and these, this is priests. Okay. Calc isn't going to help me anymore. Okay, so we have 11 acolytes. Okay. Acolytes. Okay, so thickness is currently 1. And total blocks 0 and layer 0. Okay, so while total blocks less than total blocks is less than blocks. Actually, let me start this out with layer equals 1, total blocks is 1, and we had thickness of 1 already. Okay, and now what do? We take so we bump up the layer and we say thickness is equal to old thickness times number of priests. Thickness times priests mod acolytes. Okay, and then how much of that thickness gets added to total blocks? It's thickness times it's thickness times new width. New width is 2 times layer minus 1. Okay, so total blocks plus equals thickness times 2 times layer minus 1. Okay, and then yeah, this should work. Oh, right, because what I need here is I need everyone agrees the final shape is almost perfect. Adjusting the parameters slightly empties places for worshippers to place their offerings. I guess a planned. Okay, so adjacent blocks connected on the side planes. Okay. Okay, the blocks forming the upper frame of the... How many blocks in each column should be left as empty space? The blocks forming the upper frame of the shrine cannot be removed to prevent the structure from collapse. Adjacent blocks... Example shrine and the blocks forming the upper frame of the shrine are shown here. Left as empty space in a specific column. Multiply the number of high priests by the current width of the shrine base. Multiply this result by the height of this column. Take the remainder of dividing by the number of current high priest acolytes. How many bottom blocks should be left empty for a given column? Only necessary to calculate the number of blocks a king should provide to fully complete minimal cost for the king at the same time. Additionally, the width of the structure doesn't matter. Okay. Final chosen material. Okay. Okay, multiply the previous layer by the current number of higher remainder. Add to ensure minimal thickness. Five high priest acolytes and 160 blocks available. Calculation of layers thickness would be as follows. Total number of layers. Oh, okay. Bottom blocks from a okay. The shrine width is 9 blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9. First and last columns of the height of 6 blocks is untouched if they're part of the upper frame. For columns of the height of 14, 2 blocks are removed. In total, "15 bottom blocks should be left as empty." Okay. Okay. Um, 15 blocks should be left as empty. So, columns with a height of 14, 2 blocks are removed because we have width, and we take high priest count times the width. Well, so the height of this column. Okay, so we have 2 of those. King needs to purchase an additional 2 blocks. Okay. So those are the blocks. Okay. So this is kind of like before, except it's got a lot of holes in it. Okay, so part 3. These are high priests and high acolytes. There are only 10. heights. Which there are only 10. Oops. Blocks. Let's see, how many blocks? I think it's the same number, but I'm... yeah, see, there was an extra 0. One, two, three, four, five. Okay, H price is total blocks. Empty blocks. Okay, so we actually need to know all of the column heights, because the empty blocks we need to know the column heights, because otherwise the empty blocks don't we can't calculate the empty blocks. Okay, so column heights actually, let's just try int. I mean, I think int is an int64, but so okay, so we start out here 1, and then we say that the layer plus plus thickness times thickness equals previous thickness. Okay, so we still start out with thickness 1. H priests percent H acolytes plus H acolytes. Okay, total blocks. Okay, and then this, well, total blocks minus empty blocks is less than 1. Okay, and now actually n column heights make int thickness and for range column heights n column heights append col plus thickness, and then n column heights dot append thickness, and now I have to come up with so then for idx ncol range, yeah, and then column heights equals n column heights range column heights if idx equals equals 0 or idx plus 1. Column heights. Total blocks equals 0. Total blocks. Okay, and now okay, and now the outer frame. Okay, so okay, so the first and last columns with a height of 6 blocks stays unchanged, are that? Okay, so I think I don't have to worry that this will cut into the frame. So columns with the height. So we do number of high priests times width. So number of high priests times width times height. So h priests times len column heights times n col okay, that whole thing h acolytes that. Okay, and now how many platinum blocks at a minimum provide to ensure that the shrine can be completed? And now this is total blocks minus empty blocks. Column heights is that. Okay. I think this will work. Not really sure. Damn. Okay, so below you can find a few more examples. Parameters above. Platinum blocks will be needed to complete a shrine with the given number of layers. Seven with 3. Oh. Well, actually, width doesn't matter, right? It's just that. Yeah. There we go. Okay. So the problem was just that I had forgotten part of the instructions that is just how many platinum blocks. Yeah. Yep. Okay, so that is number 8, and that was a little weird. The instructions were a little bit confusing, but yeah, that went pretty well. Okay, yeah, I'm just going to stop it here instead of going on to Quest 9. I don't know if I'm going to do all of the rest of these on camera. I might want to do some just, on my own. I will be pushing my code. Let us add dot git commit. Quest 8 is done. Yeah, I will be publishing my code. I'm a little bit curious now where we are on how long these take. Okay, so let's build each of these. Because if you're gonna do some kind of measurement in terms of yeah, how long the commands take, and then let's just check here. B is Quest 8. Okay, so some of them take multiple seconds. So, oh shoot, I should. Yeah, okay, so some of them take multiple seconds. Yeah. Quest 7. That was, took me a long time. Quest 5. I wonder why that's so long. Oh, Quest 5 was the one with the map, right? Where you had, like, the... Yeah. Oh, no, wait. Quest 5 wasn't the one with the map. Quest 5 was the one with the weird clapping dance. Yeah. Yeah, because we start out really fast. Yeah, Quest 5 was that one. Huh. Which one was the one with the map? Was that Quest 4? Yeah, that was Quest 4. Quest 4 was the one with the map, and that does not take... That takes, like, no time. Wow. I could have sworn that that would have taken a lot longer. But, yeah, Quest 5 was the one with the stupid map, and then... Quest 7 here. Gotta wonder if there's a way to speed up Quests 5 and 7, but okay, well, anyway, that's for another different thing. Yeah, I'm just gonna stop the recording now.